Right, so we are going to carry on our lovely journey through statistical tests and how to guide. As always, we start with a bit of disclaimers. I'm not a statistician or an expert in stat software, but I like to kind of play with both and read and learn about them. Quick run through what we've done so far. We talked about assumptions. We hammered now 15 million times on normality and scalasticity, and we are going to hammer more on those. We talked about students T, ANOVA, Welch ANOVA, two-way ANOVA, pair samples T tests, and how to run them. And today we're going to go a little bit further, but we run a very quick recap of what we've done so far using a similar method compared to what we did last time. So let's go back to our dystopic future where students are running riots because the cost of studying has increased exponentially, and residents, doctors, are underpaid and undervalued. So as we said last time, in this fictional world, we have two characters. One we'll call Matt and the other one we'll call N1, and they've started a lovely cannabis business to make up for their student debt and survive through their weekly shopping. So let's recap very quickly. If you remember, N1 was running a plantation of cannabis, and he had planted two rows at two different temperatures. And Maddie was asking him how many grams did each plant give you to determine whether the temperature was actually making a difference. So do you remember, Maddie, what test did we say we're going to use here?
I think we said we'd use students' t-test.
Yeah, that's correct. So we got two samples, the two sort of different plantations, and two sets of continuous data, which is the grams that each plant gave us. So we could run a student T if the data is normally distributed, as you were reminding N1 last time. And do you remember what assumptions we were talking about?
Normality and scalasticity. Before running a student T, we need to make sure the data is normally distributed and the variances are not massively different.
Correct, yes. If obviously if the data is not normally distributed and the variances are very different, we cannot run this type of test. Let's quickly move on. If you remember, last time N1 suddenly had a memory of planting a further row at a different temperature. So now we've got three different temperatures. What test should we run here with three samples?
So now he's got three samples, he should run an ANOVA.
Yeah, that's correct. Three samples, three continuous sets of data. And that's what we would do. And we also talked about Welch ANOVA as well, which is what you do when the variances are different. Now, if you remember, N1 also decided to try some different types of fertilizers on his different temperature plants. So we now have three rows using different temperatures and different fertilizers. So what test should we run?
A two-way ANOVA.
Yeah, that's correct. So we are looking at two variables in this particular instance. We then wrapped up last time with a final question, which was N1 had noticed that the plant looked a bit floppy, so decided to give him a little bit of fizzy water. And he counted the leaves before giving the fizzy water and after giving the fizzy water. And the question is, has the fizzy water made any difference? So in this case, we are talking about paired sample. Matt, do you remember what test we said we were going to run here?
That'd be a paired t-test.
Yeah, that's correct. So an intervention is performed and the data is collected again on the same sample. And we'll go through what paired samples are again, just to reinforce the concept. Now, let's add a little bit more. Obviously, N1 woke up the following morning and realized that the plants actually responded pretty well to the fizzy water. And he thought, well, I should give him a little bit more. But unfortunately, he picked up lemonade instead. So what scenario are we now in, Maddie?
So the samples are still paired, but there's 3 interventions and data is collected at 3 different time points. So I think a repeated measures ANOVA should be what N1 needs.
Correct. Absolutely correct. So we're going to talk about repeated measures ANOVA, but since you are very clever, you also remind him that he's got to check for sphericity. What the heck is sphericity? Oh, well, it's a concept I've recently encountered myself, so we'll dig into it together and we'll figure it out. So before we move on to the actual lecture, let's see where we are in our map. So we're still looking at continuous data. We're still looking at data that is normally distributed, and we are now digging a little bit more into ANOVA. And again, to demonstrate, we're going to use Jamovi. Now, ANOVA is, as you probably remember from the last 2 lectures, a product of the statistical genius of Mr. Fisher. Now, Fisher had published a number of papers on statistical methods when he was working at the Rotham's Head Experimental Station. And those studies are called Studies on Crop Variations, and I think there's 5 of them. Allegedly, they're all enlightening documents. I can't encourage you to read them on one because I think that'd probably be a bit too much. But certainly, having a look at how Fisher's contribution, looking at crops, changed the way we do medicine today is fascinating. And he probably doesn't get enough credit for what he did to change the way we do what we do in research. So moving on. When we were talking about the paired sample t-test, we talked about paired data. And as we said, paired data is a set of data where each data point in one group has a corresponding and meaningfully connected data point in the other group. And the most common scenario that you encounter in medicine is, I've got a patient with high blood pressure, I'm going to give him some treatment, and then I'm going to measure the blood pressure again. So each patient has got a blood pressure before and after having had treatment. Now, when we go into repeated samples ANOVA, we're still talking about paired data, but nothing stops us from measuring it at the start, after the first treatment, and after another set of treatment. Potentially even doing cumulative treatment, so giving them further medication, such as, I don't know, amlodipine and then an ACE inhibitor. I don't even know if you do that nowadays because I've not done blood pressure management in ages, but that's just to give you an example. So again, you measure the baseline, you do something, you measure again, then you do something again, and you measure again. So you end up with basically 3 pots of data which are all linked to each other. Let's look at the assumptions that we need to take into account when we run a repeated samples ANOVA. The first one is always normality. Normality, normality, and then normality again. Remember to always check that, and we looked at how to do that a few lectures ago. Obviously, it assumed that samples are paired, otherwise we wouldn't use this technique. And the sample should be big enough for, sort of this result to be representative. And we discussed how big the sample should be is rather open to interpretation. We did that a few lectures ago. Now, let's talk about assumption number 4, also called sphericity. Now, before we actually explain what sphericity is, I need to tell you a couple of things about levels and scores. Now, when we run a repeated measures ANOVA, we talk about level. A level is a point when the measure is taken. Let's talk about blood pressure. It's the blood pressure baseline. Baseline is one level. Then we give the meds, we measure 3 months on the line. So 3 months on the line is another level. And then 3 months on the line again, and that's another level. So we got level 1, level 2, level 3. And then we talk about scores. Scores are the values that are recorded for that particular subject at that particular time point. So for level 1, patient Jack has got a blood pressure, which is his score at that point. At level 2, Jack has got a different blood pressure, which is his score at that particular point, and so on. I hope it makes sense so far. Now, when we talk about sphericity, we need to look at the difference between scores, so in this case, the value of the blood pressure, between the different levels. So if we measure a blood pressure at time point 1 or level 1, as it is highlighted here, and then we measure at level 2 and then at level 3, we then have to calculate the difference between the score at time point 1 and the score at time point 2. The score at time point 2 and the score at time point 3, and the score at time point 1 and the score at time point 3. So the difference between any two levels, and the variance between the different levels for this difference that we calculated has to be constant, or at the very least, not dramatically different. And there is a specific test that you can run to check that that is the case. And Jamovi allows you to run that test. I hope it makes sense, but we'll have a look at a pragmatic example. So going back to my lovely dissertation, if you remember, and it's probably now imprinted in your brain as much as it is in mine, I did collect data about papers that were advertised on Twitter by a number of publishing journals. And for the purpose of this particular example, let's assume that those papers were treated first using simple text, then using a picture, and then using a visual abstract. Now, this was done sequentially. So basically, we've got the same papers, and we've got 3 different levels: text, picture, visual abstract. Let's have a go at doing it with Jamovi. Now let's go back to our lovely overall data set. So the repeated measures ANOVA is conveniently found under ANOVA, and it's actually labeled pretty well. Now, slightly more complicated than normal. You've got to actually name the levels. So for the purposes of this example, we're going to name them text. The second one is going to be named picture. And the third one is going to be named visual abstract. Okay? And then we are going to put our actual continuous numerical variables here. I conveniently pre-labeled them, so I know that this goes there, that goes there, that goes there. And there you go. As you can see, Jamovi runs the test, obviously pretty quickly. It's a computer. And as you can see, the results is statistically significant. So there is a difference between the various levels. You can also look at the between subject effects, and you can also conveniently check the assumptions. And there is, look at sphericity test. There you go. And as you can see, this is statistically significant, which tells you that the assumption is violated. So I shouldn't have run this test. However, for the purposes of showing you how to run it, I did. Now, this is a very simplified version, what I've explained to you, of repeated measures ANOVA. And I cannot pretend to fully grasp the complexities of Fisher's calculations and how he designed all this. But there are many more uses for this particular type of test. And if you go online and look at the tutorial for repeated measures ANOVA on Jamovi, which the people that actually designed this software have produced, it does give you a much a broader overview of the features related to this test. But for the purposes of this brief lecture, I'm going to stop here. I hope it is reasonably clear, the purpose of the test, and a relatively simple application of it. Thank you, guys.